Welcome to Trigonometry Identities, Alberta Education Released Items, 2019. Question 1. We've got two angles, alpha and beta, A and B, if you will. We're drawn in standard position with the point -7, -4 on the terminal arm of angle alpha and the point 2, -1 on the terminal arm of angle beta. So we're after the exact value of tan A plus B. Multiple choice question. So upon inspection, we notice that this is a tangent sum identity. So we head to the formula sheet. Formula sheet is probably our best friend with identities. So we've got this particular one. So what do we need? In order to simplify, we would need the tangent of A and the tangent of B. So how do we get that? Well, we've been given the information. We just have to do a few things to get it. So we're going to draw the given terminal arms in standard position and determine the ratios that we need in order to get the answer to this identity. We'll start in quadrant 3. So the point was -7, -4. So if we drew the triangle, standard position, the tangent of A is 4/7. Opposite over adjacent, negative over negative is a positive. And then we would go to quadrant 4, the point's 2, -1, draw that angle, show the reference angle, which is always between the terminal arm and the x-axis. Our tangent would be opposite, -1, over the adjacent, which would be 2. So now we've got these values that we can take and substitute into our sum tangent identity. 4/7, -1/2. We'll put them into the proper spots. And then at this point, it's making sure that we pay attention to detail and working with fractions to get our final result. So 4/7 plus -1/2, we're adding fractions. We need a common denominator. At the bottom, we will be 1 minus, but we have to multiply first. 4/7 times -1/2. Don't need a common denominator there. But what does this look like as we go to the end? So on the top, we would have 8/14 plus -7/14 all over 1 plus, because it's subtract the negative, so it's plus 4/14. So we have 1/14 over 18/14. So now we're dividing. We multiply by the reciprocal of the divisor. 1/14 times 14/18. And we get 1/18. Correct answer is A. 67.2% got this one correct. Problem solving standard of excellence. Incorporating a couple of different outcomes, 3 and 6. Question 2, we have some trigonometric expressions. They can all be simplified to a numerical value. And we're told that cos theta and sine theta can't be equal to 0. Now, using the expression numbers below, arrange these trig expressions from lowest to highest. Okay, so we'll look at each expression, find out what it is, and then get our final answer. So from the formula sheet, we can see that 1 plus tan squared x is equal to secant squared x. So is there an equivalent form that can help us here for this first equation, first expression? How about we were to take this from the formula sheet, rearrange it a little bit? In other words, if we were to subtract 1 from both sides, and then subtract secant squared x from both sides, we would get an equivalent expression, equivalent equation here. Now we can use that to substitute. So instead of tan squared theta minus secant squared theta, we can substitute -1. And by doing that, it's -1 minus 1, which is -2. That's our numerical value for the first one. Now looking at expression 2, We have tan theta cos theta over sine theta. We know that cos theta over sine theta is equal to cotan theta. And then if we take the tan theta that was already there and multiply by its reciprocal, which is cotan theta, that's always equal to 1. Anything multiplied by its reciprocal is equal to 1. So expression 2, its numerical value is 1. So moving on to 3, one of the strategies for simplifying identities or trigonometric equations, expressions, is to convert all ratios to sine and cosine. And so that's what we're going to do here. So secant would be 1 over cos, and then we're going to subtract 1 over sine over cos over sine. So we have 1 over cos minus 1 over sine, and then multiply by its reciprocal of the divisor. The reciprocal of the divisor, so that's 1 over sine times sine over cos, which would get us 1 over cos minus 1 over cos, because the signs cancel off in the second part. And anything minus itself is 0. Of course it is 0. So then our lowest was 1, first expression, value of -2. Next one, value of 3, which was value of 0, which is expression 3. And the highest was expression 2, value of 1. 76.9%. Got this right. Problem-solving question. Okay, one more question here. It has to do with non-permissible values for this identity. So remember, an identity is true for any permissible value of the variable. So let's see what we got here. So non-permissible values appear when expressions have denominators where the solutions can result in a value of 0, because we can't divide by 0, it's undefined. Cosecant x, tan x equals secant x is equivalent to, I'm just going to write it out so we can see it a little bit differently. 1 over sine times sine over cos equals 1 over cos. So focus on the denominators. We're also sometimes concerned about the numerators if the numerator can be written in fractional form, but we've only got ones and sine x's on the top, so we didn't have to worry about the numerators in this case, but it's the denominators here, the sine x cos x, those two parts. So looking at the denominators of sine x and cos x, here's the question. What values of x would make these expressions equal to 0? Because we can't have them. They're non-permissible. But that's the question. Good question. I like the unit circle for these ones. Anytime we have ratios of 1, -1, or 0, I think this is really handy. So for every point on the unit circle, just remember, first coordinate is the cosine, and the second coordinate is the sine. So here are the points on the axes in the unit circle. How does that help us? Well, we're looking for cosine 0, which would be up here at half a pi or 3 pi over 2, cosine 0, or sine 0, which would be over here at pi or 2 pi or 0. So given the first positive terminal arm, it's half a pi. So from the initial arm, we rotate counterclockwise. We stop up here at half a pi or 90 degrees, and we see that we've got a cosine ratio of 0. It's the first one. Then we rotate another half pi, and we get a sine ratio of 0. Rotate again, half a pi, cosine 0. Half a pi, sine 0. Well, how do we write that? So the way to state the non-permissible values is n pi over 2, or half a pi n, if you will. Every half a pi, where n is an integer, we will get a cosine or sine ratio that is 0. Those are the non-permissible values, and so the correct answer is C. So as you can see, this was a challenging question for a good portion of the population. 47.5% got that one. Okay, a procedural type question, standard of excellence. And that concludes this edition of the Trigonometric Identities, Released Items, Detailed Solutions.